We have a circle, and perfectly inscribed inside it is an isosceles triangle, ABC. Our goal is to find the exact radius of the circle. Let's start with the information we're given. The two equal sides, AB and AC, are both 5 units long, and the base, BC, is 6 units long. That's it, just 3 side lengths, and somehow we need to find the radius of the entire circle. The first step is to drop a perpendicular from the top vertex A down to the base BC. Let the foot of that perpendicular be point D. Because the triangle is isosceles, this perpendicular also bisects the base. So the 6-unit base is split perfectly in half. That means BD equals 3, and DC also equals 3. Now look at triangle ABD. It's a right triangle. The hypotenuse, AB, equals 5, and one leg, BD, equals 3. If you recognize the famous 3, 4, 5 triangle, then you immediately know the remaining side. AD equals 4. So we found the height of the triangle. Now comes the clever part. Extend the segment AD downward until it hits the circle again at a new point, E. This creates one long vertical line from A all the way to E. Why is that useful? Because AD is not just any line. It is the perpendicular bisector of the chord BC. And there's a beautiful theorem in circle geometry. The perpendicular bisector of a chord always passes through the center of the circle. That means the center of the circle lies somewhere on the line AD. Let's call the center O. Since the line passes through the center and connects 2 points on the circle, A and E, the segment AE must be a diameter. So if we can find AE, we can immediately find the radius. To do that, we need the length of the small segment, DE. And this is where the intersecting chords theorem comes in. The theorem says, when 2 chords intersect inside a circle, the product of the 2 segments of one chord equals the product of the 2 segments of the other chord. In our diagram, the 2 intersecting chords are the vertical chord AE and the horizontal chord BC. They intersect at point D. So the theorem gives us AD multiplied by DE equals BD multiplied by DC. Substituting the values we know, 4 multiplied by DE equals 3 multiplied by 3, which means 4 times DE equals 9. Divide both sides by 4, and we get DE equals 9 over 4. Now we can find the entire diameter. The diameter AE consists of AD plus DE. That's 4 plus 9 over 4. Let's rewrite 4 as 16 over 4. So we have 16 over 4 plus 9 over 4, which equals 25 over 4. That's the diameter. But the question asks for the radius. The radius is exactly half the diameter. So we divide 25 over 4 by 2. That gives 25 over 8. And that's our final answer. Don't forget to like the video and subscribe for more, and I'll see you in the next one.